Hi, everyone. Super excited to be here, especially since we've already had a design speaker this morning. So it's fantastic to kind of see more of this at Gaia happening. However, the imposter syndrome is very real when you're a designer in a room with so many machine learning engineers. So please do not ask us anything about the actual models. We have we have a full team with us that is happy to actually take those questions. So yeah, I think we're going to just start right with it. We come from a company called Record the Future. We've been around for about 15 years. We're in the space of cybersecurity, which means that we work with customers to really secure their environments, their own clients' data, and this can happen within within various sectors, within the government, within the public sector, within a lot of private companies as well, of course. And we're a company that has been founded and started in Gothenburg, actually, for many years ago. However, our main office right now is in Boston. And here in Gothenburg, we keep quite a presence, I would say, with our R&D, with our whole R&D department. If you're interested in talking more about who we are and what we do, we actually have a booth here. We are part of quite I want to call it a small but very mighty team of designers, researchers, a lot of machine learning engineers, many of which are present today with us, so do come and say hi. But again, we represent all of their work as well. This is threat intelligence. I don't know how many of you know what it actually means, but I think what it really translates for us as a product is that we collect a lot of data from across various sources from the internet. We index this data, we try to structure it, we try to organize it, and together with data that our customers really offer us, so when it comes to their telemetry, their tech stacks, their domains, so things like their brand names, for example, we try to really serve them with a digital twin of the internet that says where they are impacted. So we send alerts about what kind of threat actors might be interested in their industry, what kind of ransomware activity might be prevalent in certain sectors. We also, for example, try to map if there's been different leaks and so on. In doing this, we build what we call the intelligence graph. So this is a graph database that, as I mentioned, is a digital twin to the internet. So that makes our challenge as designers and researchers really trying to figure out how do we best create interfaces for our users, for our customers, to get the best out of this data, right? So trying to query this intelligence graph, trying to understand, what kind of threats are they impacted by. And we have done this for many years. We've applied AI in various forms. Really, since the beginning, we call ourselves an AI native company. Daniel, who was here before, he's been one of the early people that we also had on board. But of course, as everyone else, we're also trying to investigate where can we apply generative AI today to really make use of the natural language interfaces that we can provide our customers. So if you want to generalize what we're going to be speaking about today, it's really knowledge discovery in graph databases. With this, we're going to try to present really the research that we've done, and this is going to be the part that my colleague Björn is going to cover, and then we're going to see how this applies in the product with some very specific interface examples.
Perfect. Thank you, Ruxandra. So I'm actually going to give you like a preemptive warning here that we've cleared with the staff here as well. Like, we're likely going to eat up a lot of our Q&A time talking about these different principles. As Ruxandra mentioned, I think we feel a little bit nervous about not being the machine learning people here, talking in front of a computer science crowd. I think once the excitement of us getting accepted to Gaia started dying down, I think we realized, like, oh, wait a minute, how are we supposed to cover all these different things? So we might eat up quite a bit of that time. But again, as Ruxandra mentioned, we have a booth here, so it's very easy to find us if you have any questions for us afterwards, I think. So what we want to cover today is kind of how we are trying to merge theory and practice for ourselves to create new interesting AI tools for our users, and also to, of course, how we continuously try to improve them over time. And that's like a twofold approach. Of course, we do continuous like in-house UX research where we continuously talk to and interview our different users about what they like about our current products, but also what they would like to see in our future developments, like what their expectations are, what their attitudes might be towards AIs, what their concerns might be when it comes to trust and those types of things. Since we're in the domain of cybersecurity, of course, they have a very like low tolerance for risk and a very, very high premium on us delivering like reliable, trustworthy, authentic AI experiences, right? But we also send out regular surveys and, of course, track in product behaviors by looking at user metrics, as well as like doing some prompt analysis to see how people interact with our natural language interfaces. But we also supplement this with a heavy dose of like theory. We do continuous like regular kind of literature reviews to make sure that we are up to date with contemporary like best practices of how to design better interfaces, how to better understand like technology adoption of AI, so that we can kind of go out ahead of and smoothen out any potential issues that we might face when trying to roll out new AI features. So for my section here, I'm going to focus quite a bit on these literature reviews and talk about some design principles that we're looking at when we're trying to work with our AI. One review here was very focused on like the XAI element, the explainable AI part of this. So this has more to do with like people's general subjective experiences and feelings and attitudes towards AI, more so than how they interact with AI in the product itself. So we don't really learn all that many design lessons from that, even though we are trying to kind of address them with how we're designing our interface. Maybe more importantly for today, we also have done some extensive work trying to read up on conversational user interfaces and natural language interfaces for database discovery. Cool. So I'll start by talking about some fundamental CUI principles. So of course, the list of what makes a CUI powerful and desirable for a user, as well as the people developing it, and the pros, and the cons against using CUIs as opposed to more traditional graphical user interfaces are, of course, very, very long lists, right? But when we're looking at the papers and our literature reviews, these are the ones that usually like floated to the top and we saw by far the most of, right? The positives of using a CUI might be fairly anecdotally intuitive to everyone, right? It lowers the barrier of entry for us person being able to interact with something as complex as a big threat intelligence graph or digital twin of the internet is, of course, a very, very massive data set. It can be very daunting for our new users to like, how do I even start conversing with this data set? How do I start constructing queries that give me good information, right? So for us, of course, CUI is very powerful here in that it might lower the barrier and help people invite them into our intelligence graph better. But it's not only good for new users, like it's really good for experienced users as well, because CUIs kind of help or support emergent workflows, which is more like workflows that are more natural to the individual user. One downside of a graphical user interface, it's only as powerful as like the designers and the developers anticipate what the users want to do, right? And if the designers and developer kind of misunderstand what the users, how they like working, the user can't really do anything about it, right? So the more plastic interface of a conversational user interface lets users kind of find their own intuitive paths of doing knowledge discovery in databases, which can be quite useful. When it comes to the downsides, though, we can kind of summarize that as a CUI is fundamentally an ambiguous interface. Right, like what you're putting into the system, the way you prompt it, and what you're getting back out of it, it's kind of an unclear relationship, and that leads to some kind of specific issues here. Right, it already kind of exacerbates what is a problem with AI, which is to make sure that the user understands why the system is giving it, why they're giving them, the results they're doing. How do I change the input and tweak it to get a more desirable response back from it, right? Another very big issue that kind of is a result of this input-output fuzzy relationship is that error diagnosis and recovery can be very, very difficult. Since you don't know exactly what led to the input leading to an output, like how do you troubleshoot and make sure things are getting improved? Very, very difficult. Sometimes the user don't even know that there is like a user error on their end, or if it's actually a system error, and again, how do they address that? Okay. In order to actually talk about this, we are going to go into some kind of design principles here. So I'm going to kind of speed run you through a bachelor's degree in design, I think, essentially. And we'll talk about the concept of affordances, which might be familiar to a lot of you, but still important to go through. So affordances is a fairly, generally applied design principle that essentially fundamentally means that every object you encounter, whether it's in the real world or in a software system, the object itself kind of screams to you how you are able or should be interacting with it. A very traditional kind of example you use to kind of describe this is the example of a door, right? And how the design of a door shows you how you should interact with it. And you are going to know how to interact with it before you even touch the door, let's say, right? It doesn't take a lot of trial experience of you feeling around on the door to see what you're supposed to do with it. Objects have perceptible affordances so that you know what to do with them before you even arrive to them. And yeah, I guess if there's any doubt of which one of us was the designer, here are my cool cartoon doors that I made. And as you might be able to see or not see, one of these have like the traditional, just a blank metal plate instead of a graspable handle, right? Whereas the other one has the very clear, handle that is made to fit your hand, more or less, right? So these things kind of signal to you the way you are supposed to work with them, right? One very clearly signals that you are supposed to push me. The other one is you're supposed to pull me. If you're extra observant, you might also see that there are some like hinges that also indicates to you which direction the door will swing. So I guess next time you suffer the indignity of pushing on a pull door or vice versa, you can actually recover some dignity, I guess, by blaming the affordances of the door. So another thing here is you might notice that the ecosystem here of affordances isn't just about the perceptible or visual interaction opportunities. It's also down to the user being able to interpret these opportunities, right? And that can kind of differ depending on the user's like skill sets with using a particular object or a piece of software, or even their professions or something like that, right? Like if you're a burglar, for example, the window will also give you the affordance of this is easy to break into, right? Which other people might not be able to see as well. So again, this is of course true for software systems as well. So the challenge we have as interface designers is like, how do you communicate all the different ways the user is supposed to use the system? Like this is a single line in your Gmail inbox, for example, and here it's of course challenging for the designer to express everything you can do with it. So the biggest challenge here is, or you can categorize the challenges here as affordances being in 3 categories. The gold standard, of course, is that all the affordances of the systems are easily perceptible. Clearly enough, everything is communicated, the user knows exactly what to do. But the challenges we have encountered the most is there are such a thing as hidden affordances, which is that the system has capabilities that the interface actually doesn't communicate. And what that expresses itself like in real life when users are using our system is the system is capable of way more than the user understands, which means that they don't make full utility of all the valuable, cool things you have developed. The other one is a false affordance, where the user gets the impression that the system can do more than it's capable of, which is of course also a problem, where a user kind of hits their head against the wall trying to do something the system actually cannot do. Right. If we're looking at CUIs, I'll give you a couple of examples here, or one example, I guess, actually. So, of course, our natural language interface isn't the only way you can query our database. Users have been able to do that for a long time. And one of the ways they're doing that in our product is with our advanced query builder, which you can see, as the name implies, it's pretty advanced, but it's also one of our most powerful querying features. And you can see that it has all these different parameters that the user is able to tweak and work with to interact with our database. So even though this is a very advanced feature and kind of, we know people appreciate it a lot, the problem is, again, the downside is that the barrier to entry of this feature is very, very high. It's very daunting to see this screen, the first thing you do, like how do you even start interacting with our interface? But from an affordance perspective, it's actually quite efficient. It very clearly communicates this purpose. This is unmistakably a database query builder. It also signals what kind of information the system contains and is able to manage. You see that you can filter by authors and sources, entities, all those different types of things, right? And also, it makes the input and output incredibly clear. You know kind of, okay, if I didn't add the correct sources, I know exactly where I should go in to tweak those things. If we compare that from an affordance perspective with traditional conversational user interfaces, of course, even though these, again, The benefit is that it lowers the barrier to entry. These are way more welcoming screens to arrive at in a new tool than something like the advanced query builder. But it introduces the affordance problem of hidden and false affordances. Like there's an incredible breadth of user interpretation here that makes them read into things like, oh, I think I should ask the system these things, but the system can't respond to it. Or vice versa, they don't really understand how to make the most out of the tool, right? So these affordance things are usually the biggest challenge for us. But I'll cut this part really, really short, I think. But the affordance principles here really only helps us design the CUI in a more powerful way, like what happens when our user sits in front of their computer and interacts with our tool. But there's also this entire world of like users approaching our tool with a lot of preconceived notions of what AI is, what AI can do. They have concerns, they have attitudes, they have whatever it might be. Because the fact is that users actually start building their user experience with you before even touching your tool. They will approach it with distrust or skepticism or excitement, which will affect the way they are interacting with the tool ultimately. Right? So one takeaway from that is like we have spent quite a bit of time trying to build a very clear profile of who our users are so that we can better accommodate their needs. Right? But Ruxandra, go for it.
Yep. So how does this all translate in practice? If we were going to sum up what Björn has identified for as design problems, it would really be kind of the classical problem of communicating system capabilities, right? But then we also have this supporting of iterative workflows when interacting with these LLM-like systems. A lot of people try to refine the output multiple times. And then ultimately, it would be also strengthening trust through explainability. So some of the ways that we've addressed that in our product has been when it comes to the communicating system capabilities, what we have really tried to work with is to identify, what would a really good prompt or input look like from a user. So on the top right here, you can see almost close to perfect prompt from one of our users, which knows exactly what they're looking for. So they're pretty specific. They identify multiple entities. They get very, very clear in what they're asking the query to do, right? And then they even they get a response and they have a great follow-up to that is again specific. This is a user that has figured out and they know what they're doing. If you look on the bottom right, on the bottom part of the picture, you can actually see multiple prompts from our users that ask for capabilities that are outside the scope of our product. So they are trying to either learn how to change their account password. They try to access features that are outside of this chat window that we offer, and maybe even get it to do multimodal features like creating graphs and so on. So here, what we've done is we've worked really hard to try to prime the user and really suggest what a good prompt is going to look like. We offer suggested questions quite up front, and we work with our users to see what works, which ones they find useful, which ones they don't. We also try to use this space to really project, again, capabilities of the system. So like creating a report is part of that capability. And then we also offer something that presents them with good practices. So in the pro tips here, you can see what kind of language would the AI really be more likely to provide a good response to. Also, how do you invoke certain capabilities? Do you need slash this in order to perhaps access certain features of the system? The second problem was the supporting iterative work. When we started this journey, so in the beginning, we really offered a version of the product that was using basically summarization. There was no interaction there. The second version we went out with was providing very short answers to user inputs. But now we have launched a feature that is very like deep research features that you see in other products. And this one made things very complex. If users could very quickly iterate, if they got a quick and short response from the user, this problem became incredibly exacerbated when provided with long-form reporting. So in order to fine-tune this report and to really make it fit, what they're looking for, they have to go multiple times back and forth with the AI. And you can imagine how how annoying it is to just try to schedule this report. They have to send a prompt that tells it schedule it on Monday, try to tell their time zone, get it right, and so on. So that this would take multiple prompts. So the way that we've addressed for this is really bring back some more of the graphical user interface and support the natural language with more of that, right? So in this particular example, the user first gets an outline of the report that they're about to create. They get quite a lot of flexibility in addressing which sections they might want. They can provide instructions per section. They can do scheduling that is in a date picker, like nothing beats a good date picker. In a date picker, and they don't need to type, yes, do generate this. Instead, they actually get a big button that says generate. So we try to really ease the interaction, make use of natural language where it makes sense, however, also support with a lot of classical graphical user interface elements. And finally, strengthen the trust. As Björn was mentioning, one of our biggest hurdles to adoption that has been, and it still is users coming in and thinking this is a classical LLM, is going to hallucinate a lot of the results that it gives me. Who knows what sources it draws from? So they come with a lot of those preconceived notions into it, especially for the profile that Björn presented, which is within cybersecurity. A user is always going to have to, as you can see here in one of the codes given by them, they will always have to answer, how did you come to this conclusion? So they will always have to, whenever they present an analysis, really go back and say, what led you to this? So in doing research with our users, we saw that this is a huge hurdle in kind of them adopting and using our AI more. Two things that we have done in product to address that. One of the first things that we really couldn't go live without was an attribution system. So you can think of this as really Chicago-style, annotations throughout the response, where the user can check exactly which data the AI took into consideration when creating that part of the response. It's also great in debugging. You can actually see, if hallucinations are happening, why they're happening, and you can go deeper, kind of, down the rabbit hole with AI. But that was not enough when it came to the long-form reporting. This is where you get into, the deep research-like functionality, where a user wants to know what does it mean when an LLM says, I've reasoned around this. What does reasoning actually mean in the AI world? So this is where we've put in place, we've really created a lot of transparency around our analysis process. So you can see in the second time I open here, you can see really all the different queries that have been pulled and all the sources that have been pulled and the analysis that has been run on them. With that said, we thank you. And if you're interested in talking more about this, either as designers, researchers, or machine learning engineers, do come find us at our booth. Thank you.
Thank you.
Thank you.